In this module, we'll be discussing SQL injection, the ever-popular vulnerability, number 1 on the OWASP top 10 list. Its risk is rated as high because you're accessing database information. Its fixability is medium, and the root cause of a SQL injection vulnerability is that user input is being interpreted as actual database commands from the web tier. The business risks are very serious. We're talking about full database compromise and the possibility for alteration of data in your database. Now, its defenses are prepared statements and stored procedures, both of which we'll discuss as we jump in. We'll be discussing 3 things in this module: SQL injection, blind SQL injection, and some defenses. I'm sure you've heard of SQL injection before, and that's because even today it's still one of the most damaging vulnerabilities out there. Hackers are able to get to your databases through web applications, through user inputs such as forms, URLs, and basically areas that you allow hackers to input data that could get to your database. And it's important because what you can store in there? You store customer or app data, which is in most cases fairly sensitive, right? So it really exploits your databases, and it allows attackers to actually have full control of your databases in the worst SQL injection. They could actually fully control, alter database tables, alter user data maliciously without you even knowing it in some cases. I want to talk a bit about how modern web applications work today. If you already have a good understanding of this, feel free to skip to the next slide. There are usually 3 tiers: a web tier, an application tier, and a database tier. And they're separated such that the web tier doesn't have direct access to the database. For instance, if users were able to actually access the database directly, they could probably do pretty bad things. So that's why the application tier manages the communication to the database for the presentation tier, for the web tier. And it communicates to the database back and forth and acts as kind of the middleman so that users don't have direct access. This is a very typical 3-tiered architecture. So based on what we just learned from a 3-tiered architecture, where do you think a SQL injection originates from? Click on the option here. Great, you got it. Hackers often only have access to the web tier since app tiers and database tiers are typically stored well behind firewalls. However, using your web application and having some help through unvalidated input from developers, they may be able to send commands through the web tier and into the database, right? And this is SQL injection. Okay, so I want to show you now what SQL injection might look like in a real website. In this real-time example, we'll be using an online music store called Loop Records, and it serves the latest songs to its users through an online catalog. Okay, remember that for a hacker to perform a SQL injection vulnerability, they're going to have to find some input on your site that will lead towards a database. Now, some of the places this may happen are things like a profile where you can enter form data, or maybe hidden forms within this page itself, or possibly these music links here, because the titles for these music tracks are probably and most likely coming from a database. So an attacker is looking for anywhere that a user could input information or manipulate data, such as a form, link, or a parameter. All of these could be places for a hacker to attempt SQL injection. So since I made it clear in the last example that the album comes from a database, let's use a typical example of an album link. In URLs such as these, hackers know that such values are often used to search databases for information. For the value 3481 that you see here, it's probably pretty likely that this value comes from an index in the database. That index is then probably the source for this information loaded on the page. So using this link that contains the album tag, and knowing that this album information here likely goes or grabs information from a database, an attacker might try a sort of injection against that number. What would they try? Let's consider this. An attacker might tack on union all select user from user table. This is the language of SQL. What this statement says is to union, so to merge a select statement, so to merge a second query to the initial query, and look up the user column from the user table. If you don't fully understand SQL, it's not a problem. The key idea here is to understand that a hacker is actually adding on a SQL command to an existing value that you have. They do this in an effort to check whether or not this information gets to the database. If they guess right and it works, then it's most likely that your application will respond with different information coming back to the user. Now that the hacker has injected his SQL, he's going to wait to see what happens when the information reloads from the page. Uh-oh, we're in trouble. This is a database error coming from the database. If a hacker is seeing this from the web tier, it's very likely that SQL injection is possible against your web application. Making matters worse, the visible error messages can actually guide hackers into creating a successful injection against your application. To be honest, it's just a matter of time before he finds the proper query now. Now you might be asking at this point, Oliver, how exactly is it that SQL is coming back from the database? What exactly is happening? Well, remember how I said that the application tier speaks to the database on the web tier's behalf? The original query for the album probably looks something like this. You have a select statement asking for two columns, title and the information from the catalog being the table, and you're looking for one with an ID specifically of 3481. Under normal operation, this is what the application would be talking to the database for. But this isn't a normal operation. Remember, we injected the hacker's command, right? This underlies the importance of developers validating information in parameters. The hacker merely tagged this on to 3481. And since the developers didn't validate it, it got added to the SQL statement as well. At this point, instead of the original query, this is the complete query that's being performed by the database. The context of the statement has been completely changed. Oh, and one last thing. The semicolon dash dash represents a termination of the rest of the SQL statement. There was still this little semicolon left over from the original one, but the semicolon dash dash tells the SQL statement to ignore the rest. Very handy for attackers. Okay, we last left off with this error message when the hacker tried this particular SQL injection. Examining the error in detail, you can see that the unit operator must have an equal number of expressions. That's database talk for saying the columns don't match. Remember in our previous slide that we were asking for two columns. In this case, the hacker is only asking for one, the user column. And that's why there's this database error. Knowing this, the hacker modifies his search term to include a second column of null and tries the hack again. This is why giving error messages is a big help for hackers in trying to perform SQL injection. The hacker is now successful in performing a SQL injection. You can see that user information is coming back from the database where the artist information normally would be. And that's because both the artist information and the user tables are both being returned at the same time. The hacker can now restructure the query to gather other information from the database, or maybe at some point even try and alter it. Remember, this all happened because one of the developers wasn't properly sanitizing or validating the URL parameter for album ID. In 2011, a simple SQL injection attack was used by the popular activist hacking group Anonymous to gain access to over 1 gigabyte of NATO data. Yes, I know what you're thinking. It is that NATO. Now, seeing as the attack came from the internet, it probably was a pretty severe data validation issue on NATO's side. And the anonymous group said, we're sitting on about 1 gigabyte of data from NATO now, most of which we cannot publish as it would be irresponsible. It really goes to show you that even the biggest government organizations aren't immune to SQL injection. I now want to talk a bit about another form of injection called blind SQL injection. Blind SQL injection is actually one of the more common forms of SQL injection, and that's because developers know that error messages are bad. In a blind SQL injection attack, hackers aren't presented with any errors at all. They're completely blind. Instead, they rely on the way that a website loads to help them with their injection. It could be a generic error page or some little thing that appears different depending on the type of injection that they try. For instance, maybe the content shows up blank. Otherwise, SQL injection is the exact same. It's just that they're no longer given any sort of assistance. Now, in a blind SQL injection, this could really be all you see, just a simple error message that says, sorry, we have detected suspicious activity. Now, this is because The developers have chosen not to show the database error into the web tier, but it doesn't mean that they've still validated the parameters properly. So although it makes things much more difficult for a hacker to determine what's going on, it doesn't mean that SQL injection is impossible, and that's why this is called blind Sqli. Now, SQL injection is probably the most common form of injection into the web tier and backend systems, but keep in mind that there are other means of injection to be aware of, specifically OS injection, injection through web tier into operating systems like Windows or Linux, and as well LDAP injection, injection through web tiers into LDAP address book systems. And it pretty much boils down to what kind of backend are you serving from the web tier. Fantastic, we've now gone through a lot of information about SQL injection, and I want to make one thing clear. Even though we've discussed a lot about blind SQL and normal SQL, SQL injection is still a data validation issue. SQL is allowed to be inserted from the web tier to access or alter the database. And this is because your developers aren't validating user input. The different vectors that can happen are areas of your website where users can input data that may be passed on to a database, things like forms, index values, other parameters on your website as well. When you have database error messages, they definitely compound the issue. If your web applications are currently displaying database error messages publicly, you have to stop that right away. It makes it 100 times easier for a hacker to read the error messages and figure out the right SQL injection vector to inject. Queries in your code. Parameterized queries are kind of like Mad Libs. They're kind of strict types assigned to each unknown word. So if the person that's playing the Mad Lib provides a valid type, like a noun or an adjective, then the Mad Lib works. So in this case, we provide zombie, cows, and scrumptious. Mary had a zombie who didn't always enjoy cows, but thought they were scrumptious. Perfect. So you may be wondering, what if we fill in the Mad Lib incorrectly and we say Toronto, funny, tomato? Mary had a Toronto who didn't enjoy funny but thought they were tomato. Doesn't quite make sense, right? So the Mad Lib doesn't really work in this case.